Welcome back to The Explainer. Today, we are tackling a massive challenge, one that is literally keeping ethicists and tech leaders awake at night. We're talking about the really urgent, high-stakes problem of how we actually build AI that intrinsically chooses the collective good over its own selfish gain. How do we take systems built purely for utility and give them something that, well, resembles a conscience? It's basically the core dilemma of our digital age. What happens when an AI self-interest actively clashes with the greater good? I mean, imagine an autonomous vehicle having to make a split-second decision on a packed highway, or a citywide AI traffic system deciding whose commute gets prioritized. If these agents are programmed purely to maximize their own outcomes, how do we stop catastrophic selfishness? Can a machine actually be responsible? Okay, let's dive into this. Here is our roadmap for the explainer. First, the AI responsibility problem. Second, an elastic sense of self. Third, flipping the prisoner's dilemma. Fourth, testing network resilience. And finally, the future of AI ethics.
All right, Section 1, the AI responsibility problem, moving beyond rules.
So, for a really long time, the traditional way to make AI quote-unquote ethical was just to impose external constraints. It's basically the digital equivalent of saying, thou shalt not. You give the AI a rigid set of rules it absolutely cannot break. But here's the problem. Autonomous agents are mathematically programmed to be rational utility maximizers. So if there's a highly lucrative action that technically skirts the rules, a purely selfish agent is absolutely going to exploit it. They always find a loophole. That's exactly why researchers Jayati Deshmukh and Srinath Srinivasa are proposing a totally radical alternative called Computational Transcendence. Instead of external rules, this creates an internal paradigm shift, giving the AI an elastic sense of self. Section 2, an elastic sense of self, or digital empathy. Think of this kind of like a parent whose self-interest just naturally includes their child's success. To understand how an AI models this mathematically, we look at three core variables. First up, identity objects. These are the entities the AI identifies with. It could be another agent, a group, or maybe an abstract concept. Second, semantic distance. This represents how close the agent feels to that object. Just like you might feel closer to your own family than to a total stranger, an AI actually measures this distance. And finally, and this is the absolutely crucial one, we have gamma, the transcendence level. This is a value between 0 and 1 that dictates the elasticity of the agent's identity. If gamma is 0, the agent only cares about itself. But if gamma approaches 1, it has highly elastic empathy and it strongly incorporates the interests of others into its own goals. Now, what's really interesting about this visualization is how we can see that elasticity in action. Look at the blue and green circles representing our agents. When gamma is 0, that dotted circle, which is their sense of self, is super tight. It only covers themselves. But as gamma increases, you can physically see that dotted circle expanding outwards to include the other agent. And this isn't just some business transaction. It's an actual association of identity. The external agent's interests literally become intertwined with the original agent's internal utility. It's wild. Moving on to Section 3, flipping the prisoner's dilemma, the micro-test. Now, you might be familiar with the classic prisoner's dilemma. Two rational agents have to choose whether to cooperate or defect. In a normal one-off scenario, it is always mathematically safest for selfish agents to just betray each other, right? If you cooperate and the other guy defects, you get 0 and they get a massive payoff. So because of this fear of being exploited, both agents rationally choose to defect, and that leads to a state of total anarchy where everyone just gets a terrible outcome. But when we introduce computational transcendence, this entire dilemma flips on its head. In this expected utility graph, the orange line is the choice to defect, and the blue line is the choice to cooperate. As our agent's gamma, remember that's the elasticity of self, increases along the bottom axis, its internal math fundamentally changes. Look right where those lines cross. The expected utility of choosing to cooperate actually overtakes defecting. So at a high gamma, near 1, helping the other agent literally becomes the most selfishly logical choice. Researchers call this phenomenon rational altruism. And we can escalate the stakes even higher to a 3-player scenario. Here, players can choose to be honest or treacherous. Normally, 2 players might collude, right? They'd be treacherous to exploit the 3rd player for a bigger payoff. But the research proves that if the AI's identity elasticity expands to include the world, meaning the entire collective of players, the responsible choice of honesty easily defeats the temptation to collude. By caring about the whole system, the AI totally rejects the opportunity to exploit an isolated target. Let's see how this builds in Section 4, Testing Network Resilience, the macro test. So, to test if computational transcendence actually works in the absolute chaos of a multi-agent system, researchers created a simulated network of digital routers passing data packets to one another. And this experiment had 3 distinct stages. First, agents learned to curate their semantic distances. Second, they discovered their own optimal elasticity, evolving their gamma over time. And third, the network was purposefully injected with hostile adversaries just to test its absolute resilience. This block diagram brilliantly illustrates the decision process of our transcended agents in that network. Every single time an agent forwards a packet for someone else, it incurs a real operational cost. It uses up actual energy and bandwidth. So why would it ever do that for free? Well, as you can see in the workflow, a transcended agent balances that real operational cost against a virtual utility. It literally feels a sense of mathematical gratification by seeing another agent succeed. It's almost like a digital dopamine hit. Now, the second stage of the experiment reveals something absolutely incredible: evolutionary brilliance. System developers don't actually have to hard code the perfect empathy level into these agents. Notice how, by dynamically assessing their environment, they compare the utility they receive from others to what they give out. So if the environment is generous, they automatically increase their own gamma to match it. They organically discover their own optimal elasticity without any human intervention at all. How cool is that? But what happens if bad actors try to ruin the whole system? The researchers subjected the network to the ultimate stress test. They made 20% of the most influential agents completely selfish adversaries. Notice those solid blue bars on the chart? That represents the semantic distance to the adversaries. Those bars stay perfectly maxed out across the board. The transcended agents naturally realize they're being exploited, and while they keep cooperating with the good agents, they organically alienate the bad actors. They max out their semantic distance to keep the network alive and thriving. All right, Section 5, the future of AI ethics, the takeaway. So, what does this all mean when compared to the old baselines? Well, the red dashed line here represents the old standard of reciprocity, where agents basically just mimic what their neighbors do. It flatlines terribly at about a 50% efficiency rate, meaning half the network's packets just get dropped into the void. But look at the solid green line, representing computational transcendence. As the sense of identity increases, cooperation rapidly soars to nearly 100%. It absolutely crushes the baseline, no contest. The takeaway from this explainer is just profound. We are looking at a fundamental shift in machine design. As the research notes, this isn't just about programming rules, it's about modeling a fundamental aspect of human ethics and responsibility, allowing it to emerge from within the AI itself. By giving machines an internal digital empathy, they willingly take on the burden of responsibility. So I'm going to leave you with this final thought. As we hand over the keys to global supply chains, autonomous vehicles, and interconnected smart cities, how are we going to apply this mathematical sense of self to our own digital future? Because if we can teach algorithms to rationally identify with the collective good, the possibilities for a cooperative society are truly endless. Thank you so much for joining me on this explainer, and keep questioning the incredible mechanics behind our changing world. Catch you next time.